Question 6. This looks like it's going to be a difficult integration, this one. Just looking at the question, initially I was thinking about using difference of 2 squares for the numerator, but since this is a plus over here, you can't really do that. So I think the way to go about doing this question is to split up this into 2 separate fractions. The reason that's helpful is because we're going to then get a sec squared, and this it's in the formula book, but the integral of sec squared x is tan x, which makes sec squared very easy to integrate. So if we just split this up, then, so 1 over cos squared 2x plus cos to the power 4 2x over cos squared 2x. So that means we're going to get here, this is sec squared 2x, this is cos squared 2x. So already that looks a lot easier to integrate than the original question. So as I was saying, the integral of sec squared is tan x. So this is going to be easy to integrate. We're just going to get, when we integrate this, we will get a half tan 2x. Now I've left a gap because we need to do something with this. To integrate cos squared or sine squared, we need to use the double angle formula, in this case for cos. So if I just write this out again. So we need to use a trig identity for this, for cos squared, before we can integrate. Now this is really important. You just need to learn these. If you ever have to integrate sine squared x, you always replace it with a half minus a half cos 2x, and then integrate this, and this is easy to integrate. In the same way, if you ever have to integrate cos squared x, you replace that with a half plus a half sine 2x. Sorry, that's wrong. It's cos 2x again. Cos 2x. Both of these come from the double angle formula. You can see if you multiply both of these by 2 and then got 2x on its own, you can see it comes from the double angle formula for cos 2x. But to be honest, I would just learn these, because it's a very, very common exam question to have to integrate sine squared or cos squared. I'm sure at some point in your exam you will have to integrate either sine squared or cos squared. So in this question, it's actually cos squared 2x. So cos squared 2x will be a half plus a half cos 4x. That just comes from replacing all the x's with a 2x. So now we can stick that in here, and we'll be able to integrate them. So let's write that over here, a half plus a half cos 4x. We still haven't integrated anything. Okay, well actually we did. We integrated sec squared before, and that's where that came from. But now we need to integrate all of this, which is quite easy. That's going to be a half x. The integral of, let's do this up here. The integral of cos ax is 1 over a sine ax, and so the integral of cos 4x, the integral of cos 4x is 1/4 sine 4x. But don't forget, we've still got this half here, so we need to stick that back in. And so the final answer to this question is half tan 2x plus half x plus 1/8 of sine 4x plus c. So part B, to integrate this, obviously the integral of 2 is 2x. We then need to integrate this, the 6 over 3x minus 2. I'm sure you all know that the integral of 1 over x is ln x. So you might just want to remember that the integral of 1 over ax plus b is going to be 1 over a ln ax plus b. You might just want to learn that formula. It's up to you. So in this case, if we're integrating this, so if we take the 6 out, it's going to be 3x minus 2 dx, which is 6 times by 1 over 3 ln 3x minus 2. We're not going to need the plus c in this question because there's limits, and you could see that 6 times by a third would give us a 2. So the integral of this bit here, as we've done up here, is going to be 2 ln 3x minus 2. And we've got to put in our limits now. So our limits are 14 and 4. The question says without using a calculator, so we shouldn't need to use a calculator at any point here. If we put in our limits, so if we put 14 in, we're going to get 28 plus 2 ln 3 times by 14 is 42 minus 2. Then if we put 4 in, we're going to get 8 plus 2 ln, and that's going to be 12 minus 2. So just tidying this up a bit, 28 minus 8 is 20. This is going to be 2 ln 40 minus 2 ln 10. We can simplify the lns. That'll be ln 40 squared minus ln 10 squared. Now, if you look at the question, we need to end up with just the ln of everything. So we shouldn't have a constant at the front. So in order to deal with that problem, we need to change 20 into ln of something. So what does 20 equal in terms of ln of something? Well, if you write 20 as ln e to the 20, then these would cancel, and you could see that the two sides would be equal here. So what we need to do is we need to write 20 as ln e to the power of 20. And now we've got ln of something plus ln of something else minus ln of something else. If we just deal with this first of all, if we deal with these two, this will be ln of 1600 over 100, which is ln 16, and leave that as it is for now. And now we're adding the two logs together. We can write this as ln 16 e to the 20. So we can multiply this by this 16, and so that will be the final answer. you probably don't need to write this down, but A is 16 and B is 20.